Nitric acid is a very important industrial chemical. It has some other important uses, like it is used in the preparation of fertilizers like calcium nitrate, ammonium nitrate. These are all very important fertilizers. It is also used in the manufacture of explosives. And nitric acid is also an important constituent in some dyes, drugs and perfumes. So it is a very important reagent. Let's see how we can prepare nitric acid. We know the reaction that when a salt reacts with an acid, it forms another salt and another acid. So we'll take this reaction for the preparation of nitric acid. We take the salt potassium nitrate, we make it react with an acid, that is sulfuric acid. The condition required is that they are heated above 200 degrees Celsius. So when a salt reacts with an acid, it forms another salt, that is potassium sulfate, and another acid, which is nitric acid. So in this case, we had to prepare nitric acid. So we start with the two reactants, potassium nitrate and sulfuric acid. So this is the experimental setup. We take potassium nitrate and sulfuric acid in this. It is heated. The vapors of nitric acid are evolved, and these vapors are further cooled to change the gaseous nitric acid into liquid nitric acid. So you observe that when potassium nitrate and sulfuric acid, they are heated, a gas is evolved. These vapors are of gaseous nitric acid, and when they are cooled, they form the nitric acid. So this is the reaction taking place that we had seen. Potassium nitrate reacts with sulfuric acid. One salt plus one acid gives another salt and another acid. The acid, nitric acid obtained in this case, is slightly yellowish brown in color. This is because HNO3 decomposes in the presence of heat to form NO2, H2O and oxygen. Now this nitrogen dioxide gas is brown in color. So it gets dissolved in nitric acid, hence giving it the yellowish brown color. So this nitrogen dioxide can be removed by some other techniques and by careful prevention of the decomposition of nitric acid. So then we can get pure colorless nitric acid. But in the laboratory, we can also use some other salt like sodium nitrate. When it reacts with sulfuric acid, it also forms a corresponding salt, sodium sulfate and nitric acid, which is again yellowish brown in color because some nitrogen dioxide gas is dissolved in it. So we take this reaction for the laboratory preparation of nitric acid. Now, when we perform this experiment using this experimental setup, we have to take some precautions. All these apparatus which are used should be made of glass. This is because nitric acid is very corrosive in nature. It corrodes the rubber corks or other substances other than glass if we take. So the first precaution that we take is that all the apparatus is used of glass. So we use all glass apparatus. Secondly, we had used sulfuric acid for the preparation. Why can't we use concentrated HCl? That is also an acid. But the problem with HCl is that it is very volatile. That is, it easily changes into the vapor state. So when we are getting the nitric acid vapors, some HCl vapors also enter. Hence, we do not use HCl and we use sulfuric acid. So these are the two precautions that we take during the preparation of nitric acid. We can use concentrated HCl instead of concentrated sulfuric acid for the preparation of nitric acid. Is it true or false? This statement is false. This is because concentrated HCl is very volatile. If we use concentrated HCl along with nitric acid vapors, we might also get HCl vapors. So to avoid that, we use concentrated sulfuric acid and not concentrated HCl. So some of the properties of this nitric acid is that pure nitric acid is colorless. In the laboratory, we might get yellowish brown nitric acid. This is because of the presence of nitrogen dioxide gas. But when nitrogen dioxide is removed, pure HNO3 is colorless. It has a suffocating smell. It has a sour taste. Now don't start tasting the acid. In general, it has a sour taste. And it is soluble in water. So these are some of the properties of nitric acid.